So welcome lovers. So the topic we want to consider is on derivation of y equals to x raised to power n from the first principle. That is, we have to differentiate y with respect to x from the first principle. So what we want to calculate is we have y equals to x raised to power n. We want to find the y, the x from the first principle. So we are going to write y, then we have little change in y to it. So on the right hand side too, we are going to do the same thing, x plus little change in x, everything raised to power of n. Then from the previous video, you've learned how to expand binomial theorem. Using binomial, we have to expand this one using binomial expansion theorem from our previous video. So I made video on how this can be expanded. So that is, we are using, given that a plus b raised to power of n equals to, we have a formula, a raised to power n plus n, a raised to power n minus 1b, then we are dividing by 1 factorial, plus n into n minus 1 divided by 2 factorial, a raised to power n minus 2, b raised to power 2, then plus n into n minus 1, then n minus 2 divided by 3 factorial. So a raised to power n minus 3, b raised to power 3, plus the last term now will now be b raised to power n. Now we are going to use this in expanding this. So that is a equals to x, then b equals to delta x, n equals to n here. So we have delta, that is y plus delta y equals to x. So wherever you see a, you replace with delta x. X raised to power n plus n. A is x raised to power n minus 1. B is delta x. Then plus a is, then we have n into n minus 1. A is x. So that is, we have x raised to power n minus 2. B is delta x raised to power 2 divided by 2 factorial, plus, then here we have n into n minus 1, n minus 2 divided by 3 factorial, then x raised to power n minus 3 delta x raised to power 3, plus, then up to b raised to power of n, that is delta x. Here will be delta x raised to power of n. Now the next we are going to do, we are going to take away y from both sides, and y equals to x raised to power n. By taking away y, so that is, we are going to take away y so that we can have delta y left here. On the other side here, we take away y too, which is x raised to power n. Y equals to x raised to power n. This y will cancel this, the x raised to power n will cancel this. So we have delta y equals to n x n minus 1 delta x plus n into n minus 1 over 2 factorial x n minus 2, then delta x squared, plus n into n minus 1, then n minus 2 divided by 3 factorial x n minus 3 delta x raised to power 3, then plus delta x raised to power of n. Then the next thing we are going to do, the next step we are going to say is we are dividing through both sides by delta x. That is delta y divided by delta x. Each we are dividing by delta x, n x n minus 1 delta x divided by delta x, plus n into n minus 1 divided by 2 factorial x into n raised to power, that is x raised to power n minus 2 delta x raised to power 2 divided by delta x, plus n into n minus 1, so n minus 2 divided by 3 factorial, then x n minus 3 delta x raised to power 3 divided by delta x, we have n minus 3 here, then plus delta x raised to power n, everything divided by delta x. So in this case now, this cancel this. So this one will reduce this one by 1, this one will reduce it by 1 too. Here we will be having delta x left here, this will be delta x raised to power 2. So therefore we are going to take the limit delta y over delta x, limit of delta x tends to 0 equals to, that is, whenever you see delta x, we are going to put 0 there. Though the thing we want to apply here is that delta x tends to 0. That doesn't mean delta x equal to 0, because remember, whenever you are dividing with 0 is undefined. So that is, when x is approaching 0, delta x is approaching 0. Whenever delta x is tends to 0, it implies that delta x is very close to 0, not that delta x is equal to 0. So therefore, whenever you see delta x, we are going to put 0 there. We have n x n minus 1 plus n into n minus 1. So then, as you are taking the limit of this, so delta y over delta x, as delta x tends to 0, we change to the y dx. So as you are taking the limit of this one, delta y over delta x, so as delta x tends to 0, so equals to the y over dx, which equals to n into x n minus 1 minus 1, then plus n into n minus 1 divided by 2 factorial x n minus 2. Then this one will be, that is, when we divide this one by this, we are going to have delta x, and delta x equal to 0, we put 0 there, plus n into n minus 1 n minus 2 divided by 3 factorial, so x n minus 3. Then this will be, when you divide this one, it will be 0 raised to power 2. So plus, so delta x, when you divide delta x is defined by delta x, you are going to have delta x raised to power n minus 1. And we have to substitute 0 there. We have 0 raised to power n minus 1, which will be 0. So which implies the y dx equals to nx n minus 1. So this is the formula we will be using when it comes to derivative of a given function. That is, the y dx, this is derivative sign, equals to nx n minus 1. Please write this one down so that we'll be using it in the nearest future. Thank you.